I was at trash toss. Yeah, on Sunday. Yeah. Dude, I wish that, you know, you see like the person attacking, you know, pulls the leash or something like that. I always that's pretty good here. I'm looking to see that.
2526. What questions do you have? Substitutions and numerical methods. Yes, Mia.
6 for number 4, we just have to put the table in, we have to show all the calculations by 3.
Yeah, it just says use a numerical solver. Construct the tables. Yeah, that's it. If you're using a computer for that, if you do it in Excel, that's fine.
So we just like use our calculator.
Sure. Or the example that I put on Canvas that is an Excel sheet, or there are numerical solvers on several websites. I think if we go to our Canvas page, web links, here we go. We've got a direct set to a differential equation solver down here at the bottom, Math 24 Pro. There's a numerical methods section in that. Symbolab has all 4 of those bottom ones are links that will take us to numerical solvers. Slope's got one built in. So there are a lot of different ways for you to do that part. The calculator program is easy if you're good at editing in the function sort of deal. Otherwise, it's whatever you think is most appropriate. That's why we can do these things in Excel. Everybody's got it. More questions?
So does that mean in 10, we're doing the like numerical solver and doing personals? This is
Well, it says use numerical methods and Euler's method, right? So if I use the numerical solver, I can use that for anything, right? But they want me to use the numerical solver using Euler's method. So that's, I think, what that and means. Because if I just type, hey, give me a numerical solution to this, it might use one of the Runge-Kutta methods, or it might use a spline method or something else that we haven't talked about yet. I want to make sure it's using Euler's method. Although I will say that I believe the most common one first available is Euler's in almost all the numerical solvers I've run into. What else you got for me, people? Yes, Chad.
Could you show how to like edit again?
Sure. Absolutely. So if I'm in the program for Euler's method on the calculator, program, edit, I go down to Euler. I'm looking for the line with the arrow and the K. Once we get past all the inputs, there's the line. It's the first line in the loop for J goes from 1 to N by ones. So everything in front of the arrow K here is what I want to change to our equation. As long as I don't destroy the arrow K, I can just type in my equation. Remember, there's no X in here. I've got to use T instead. Okay. Other than that, so if I was doing, say, 10, where it's y minus y squared, insert y minus y squared. Then the next line is take the step in that direction, add it to the y we used to have, make that the new y. Oh yeah, and step up x as well. So this first calculates f prime, then calculates the next y, and then the next x. So that's what these three lines are exactly doing. And it just spits those numbers out, display the new x and the new y. You have to hit enter. That's what the pause is for. And it keeps doing that until you've done all n of them. So the only line you'll ever need to change is this one. You're welcome. Once you finish, by the way, second quit, and then you're out of the program. So let's see, that was number 10, and it started with y of 0 is 0.5. Program, Euler, put the function in, 0 is 0.5. And then we were going to take 5 steps of size 0.1, right?
Yeah.
5 steps of 0.1. There we go. And now it starts running through. More questions? Yes, no.
We did about like number 10 on 2.6, I believe.
So that was the one with the y and the y squared, right?
Yeah.
So that's what we're asked for, yes?
Yeah.
So that's our x0, that's our y0, and that's where we want to get. And it says that I should use a step size of 0.1. So formulaically, to get the next y value, I calculate the slope at the current y value and x value, multiply by h, and add that to the y. I'm starting with 0. So to do 1, I do y0 plus something times 0.1. And the something comes from here. Evaluate what's in those parentheses. So this is 0.25 times 0.1 plus 0.5. So that's 0.525. And that goes with x1 being 1 step over. Really, it's 0 plus, let me write it this way. Xn plus 1 is xn plus h. So it's 0 plus 0.1. That is step 1 of 5, because I have to get from 0 to 0.5. So I got to do 5 steps, right? Just do it again and again. Y2 is 0.525 plus 0.525 minus 0.525 squared times 0.1. I don't know what you're gonna get out of this. But whatever you get out of this is gonna go back in to get Y3. In all three of these spots, because that's Y plus Y minus Y squared times H. Make sense? So it actually says to do this twice. The first time with steps of 0.1, second time with steps of 0.05, means it's just going to take 10 steps the second time, where it only took 5 steps the first time. But that is the best part about doing it here, or on Excel, or in one of the symbolic sites. It'll just copy and paste and you're done. Trust me, if something is easy to code, we should code it. What you got for me now? More questions. A remark about the exam review sheet. Please notice what is written at the top of the exam review sheet. Took it right off the candidate page. So when you go to look at it, it'll be right there at the top. It's just like all the other courses. We did this in discrete. Yes, yes, yes. Mia, do you ever get into trouble wearing that shirt? Say, because Bucks is an abbreviation for Buckeyes versus Bucks is an abbreviation for Buccaneers. People will get pissed. You're wearing a Go Bucks. Yeah, but you're wearing a Go Bucks shirt in Pittsburgh and it's not red, it's not black and gold. People might be upset.
I actually had someone, say they like my shirt.
You had some.
I had someone say they like my shirt.
It's a great shirt, but it's one of those, I wonder if there's a regional issue here.
Your
I-
number 8 on 2.5.
8 on 2.5. Okay. So dy dx equals x plus 3y over 3x plus y. Now it says I'm going to need a substitution. So my first reaction would be, how do I know I'm going to need a substitution? Well, I start by saying, oh, this is set up for separable, isn't it? But if I go to cross multiply, it's not separable. Maybe it's exact. 3x plus y dy equals x plus 3y dx. That's how I know it's not going to be separable, because my x's and dy's are mixed together. If I move this over, well, we'll write it this way: x plus 3y dx minus 3x plus y dy equals 0. Then it's m dx and n dy, but the partials are not the same, right? My is 3 and x is minus 3. It's not exact. And given the way it's written, it is definitely not linear. So that's how I know I have to do something. And the recommendation is a substitution. So there are 2 different substitutions that spring to mind for the way we set stuff up Friday. Either I'm going to use x over y or y over x. And it's really your choice, because I'm not sure which one's going to work better here. It's a coin toss. Which one did you try? You didn't. Okay, well then I'm going to say what we should do is pick one. Which one do you want to try? I'm not sure if I've actually got the letters right, by the way. I don't remember in the textbook whether they tell me that u is x over y or v is x over y, but it doesn't matter. I could use whatever letter I want. Okay, so we're going to try this one. So the other way of writing that is to write xv equals y, right? Then take the differential. What is dy based on this? Right. So now I go back up to the equation. And I'm going to take this equation and rewrite it with this. So x plus 3xv dx minus 3x plus xv dy. X dv minus v, I'm sorry, plus v dx equals 0. Now, what I am hoping is that I will be able to multiply all of this garbage out and some stuff will cancel. And the resulting equation, after I do all the canceling and rearranging, is either separable or linear. And I can solve it. It might even be exact. But I'm going to have to do the algebra from here on down. So you do that, and we'll figure out where we are. Oh. I know I can do this kind of substitution because it told me at the top of this set of problems that this differential equation was homogeneous. And this is the substitution for homogeneous equations. I knew it was, I'm like, I didn't check that it was homogeneous. Oh, the book told me that. That's why I know I can do this. So with a large amount of algebra, I end up there. Talk to me, Mia, because I could have screwed something up. Oh, you're absolutely right. Because I pulled the minus out front here, that changes that to a plus. Good catch. Hey, wait a minute. What do I do over here?
72.
Not until I'm done. I still haven't solved this equation. This is separated, isn't it? I got to integrate both sides. V over 1 minus v squared, that's a u sub. But 3 over 1 minus v squared, that's partial fractions. So really, the way to do this is to break it into two separate pieces. This one is easy because it's a u sub. This one is partial fractions.
So. Like, do you think it would have been different if we had the other substitution? Or,
It would have been different. Would it have been easier? I doubt it. Why do I doubt it? Let's go back and look at the original equation. Those are almost symmetric, aren't they? If I use x over y and I do dx instead, then I'll just have all of those moves over here. And it might be, I don't know, instead of 3 plus v, it might be 3 plus u over 1 minus u squared. It might look almost the same. I'm not 100% sure, but it'll look really close, unfortunately. And that's only because the two pieces looked so close in the first place.
I don't know, is there like a time where we think it'll be better than the other, like just by glancing at it?
Rarely, unfortunately. I don't have the experience well enough to say, oh, I see something. I think a lot of stuff is going to cancel. To me, that's rarely obvious. Cody, you look like you wanted to say something to that.
What about like the lecture you had, it was like. We were doing it, and there was a y squared plus one x dx, and then we're still negative x to y. So it'd be similar to the x squared, just close.
Right, because that one piece was much easier to deal with, right? So it probably would have been better to try and sub for that sum. But that was a hunch.
Yeah.
And I don't know, maybe it would have been easier to go the other way. I can never be 100% sure. So in this case, we ended up making our sub for y. But that one that was just a term with just an x, making a sub for x would make that term a little more complicated as opposed to the other term where I'd have x more crap to work with. But here they were just about the same. If I had done this more and I had a better feeling for it, then I might be able to say, oh, well, of course, you see this, you should do. But this is like back in Calc 2, where we had all those different integral techniques. And it was like, which technique do I need to use? Once you've seen 1,000 of them, yeah, it becomes there's a pattern. We've seen 6. So now I do the integrals. Once I've written out my equation, Noah, v equals, then I go back and substitute and write y equals. So once I get done and write v equals here, then I can write y is x times v. Make sense?
How was the partial fraction for that one?
1 minus v squared is 1 plus v over 1 minus v, plus 1. Let me do this in words. That's a over 1 plus v, b over 1 minus v equals 3 over 1 minus v squared. Find a common denominator and then solve for a and b. And I'm pretty sure, Mia, that's where the ln comes from, right? Because I'm integrating some number over 1 plus v, there's a logarithm. I'm integrating number over 1 minus v, there's another logarithm. I'm pretty sure there's a more general formula in the integral tables in the back of the calc book, but I don't remember it, so I just do the partial fractions. To me, partial fractions is always easier than memorizing more that I'm never going to use but once every decade.
Would you tell us, like you said, like, would you tell us if it's homogeneous and like that would be a substitution, or would you just say?
Solve this and hope for the best. I hope not. We should look at the review sheet and see what I did there, because I don't honestly remember what I did there. And I don't want to tell you one thing and then going up by saying, no, of course I'll never do that to you. And then there it is. So let's see. On the review sheet, determine, solve, word problem, solve. Aha. It doesn't tell you that it's homogeneous, but it asks you to show that it is. How do I know it's homogeneous? That is the T stuff. I put in a tx for x, I put in a ty for y, and then I show that I can factor the same power of t out of both the first piece and the second piece, which in this case is t to the first. Hey, that means it's homogeneous. Now I can solve with a substitution. Now here, Cody, if I run with your idea, I look at the piece over there with dx and I say that's simple. So let's try the substitution on that side, x equals.
What does it mean by determinant?
The order is what power of t comes out. In this case, the power of t that comes out is 1, so it's first order.
If we just like wrote down T, is that like self-explanatory? Say like
Somewhere I need to see the word order is. Order equals. This is why a formula sheet exists and is a good thing. I write notes like that down. This is what homogeneous means. This is what order for homogeneous means. What's next? Yes, ma'am. 2.524. Okay, it tells me it's in the format of number 5. 24, you said? dy dx over dy dx equals 1 minus x minus y over x plus y. Now that comment about the form given in 5 is that substitution for ax plus by plus c. Where is problem 5's note? There it is. So the substitution recommended is u equals ax plus by plus c. So now my question is, do you want to use the top or the bottom? I think it'd probably be easier to use the top because that one looks righter to me. Minus x minus y plus 1. But if I do that, then what's the bottom? To move those over, that goes over there. 1 minus u. So wait a second, I need one other thing. What's du? Oh, du dx. That's for the other substitution. I'm using this substitution now. Say again? But wait, there's more.
Oh, I agree.
And that means that dy dx is du dx. Wait a minute, I move that over, I move this the other way. That's negative du dx minus 1. Right? Well, now let's substitute everything in. My equation becomes minus du dx minus 1 equals u over 1 minus u. That was my reaction at first. Ready to watch me screw with your heads? This is nasty. I don't like that. But I'm going to add and subtract 1 on the top. I added 1 and I subtracted 1, right? Why is this a benefit to me? Because this is 1 minus 1 over u. 1 minus u. Ew, right? It gets better. Yeah, I promise it gets better. Watch. Put the du dx over here. I'm looking at this and my brain says, I think I made a sign error somewhere and I don't know where. So give me a minute. I'm thinking about stuff. Talk to me.
The one on, like, on the left there, if we added that 1 minus u over 1 minus u. It became 1 over 1 minus u. That would work.
But it shouldn't. It shouldn't become 1 over 1 minus u. If I add, you want me to add that back together? Or do you want me to add this
Where that minus u, instead of,
here?
yeah, just add that 1 over.
So that would be minus du dx equals 1 plus u over 1 minus u.
Adding 1 minus, take that, 1 minus u over.
Which becomes, well, that's better. I like that. That's better. because then that makes, let's write that as one line, minus du dx equals 1 over 1 minus u. That's separable. Good catch. I like that. That's better algebra. Because now I get, I'm going to move the minus with the dx. So instead of leaving the minus here, I'll put the minus down there. You okay with that? That gives me 1 minus u du equals minus dx. And that's separated. Yay! So if that's separated, I integrate on both sides. What do I get over here on the left? Equals presto. Wait a minute. U can be written in terms of x and y. Right. Okay. So what's u? U was 1 minus x minus y. There's my solution. Does it say get an explicit solution? Then I'm leaving it just like this. I'm no longer sure which is my eyes versus which is the focus. Excuse me for a second. That's better. I must have fingerprinted it because this side was blurry and that side wasn't. So there must have been a fingerprint on the lens. So you see, I was okay until I got to the algebra at the end, and I'm like, what the f do I do now? Backed me up and found a better piece of algebra. I like that. More questions.
We found du dx. You got -1 minus dx. I don't know why, but I'm like, where'd the d by dx?
I'm taking my derivative with respect to x in that line.
So it was just, I thought it'd just be -1.
But y here is a function of x. I'm not doing partial derivative, right?
Yeah.
I'm doing a regular derivative. So I'm using the chain rule here, where y is a function of x. That's where that dy dx comes from. Why I use straight lines on my d's, not curly lines on my d's. Partials. Excuse me. Hit me again. On 2.4? Oh, 2.5. 32. So let's do 31. So 31, y double prime plus y prime squared equals 0. Okay, this is a second order differential equation. And second order pisses me off because I don't know how to do second orders yet. Unless we get something really lucky. Hey, there's no y term. There's only a y double prime and a y prime, right? So let's make a substitution that looks like that. Wait a second. If u is y prime, what's u prime? Wrong direction. My second derivative, right? So that means that this equation is about to become u prime plus u squared equals 0. I like that because that is separable. Nope, that's a u over there on the left. Wait a minute, that's separable. You can solve it. What do I get on the left? Oh. Okay, what do I get on the left?
Equals index. Let's see.
Hey, wait a minute. You know, there's a minus on both sides. I could cancel it out. Well, that makes 1 over u equal to x. Technically, it would be minus c, right? But a constant's a constant, no matter what sign it is. So what's u? But go back up to the top of the screen. We decided that u was equal to y prime. So this really says y prime is 1 over x plus c. Now you can solve for y, can't you? Integrate again. What we did is we took a second order differential equation, made a substitution, turned it into a first order differential equation. You ready for the sneaky part? This is called reduction of order. Because it's really not a second order differential equation. It only involved a function, which I decided to call u, and its first derivative. In spite of the fact that it was originally looking like it was written in second derivatives. If you go back to the calc class, I'm pretty sure it's in chapter 9, so it's in calc 2. We had the temperature between two spheres. We knew the temperature, one was 15 degrees Celsius, the temperature, the other was 25 degrees Celsius, and they were like a unit apart. And we were told about the second derivative, but we did this reduction of order and it turned into the same thing. We've seen this. I had the weirdest sense of deja vu. I've seen this crap before. More questions, more ideas.
About the algebra.
The algebra on 31.
The real problem is just the.
Oh, this one? Or this one?
No, the problem being
Oh,
what is du dx is the weight of u squared.
Right.
So how do you get to that next time?
divide by the u squared, multiply the dx over. You could have also moved the minus sign as well, right? You could have written that line as -1 over u squared equals dx, because then the integral of this is u to the -1 equals x plus c, which is exactly where we ended up right here, isn't it? I realized it afterwards because in the previous one I kept the minus for the dx, and here I decided I'll keep the minus for the dx. Oh, but if I moved it, it would have made the signs easier. More questions, more questions. So when I start writing things down on my formula sheet now, I tend to write down the definition. A function is homogeneous if. Differential equation is homogeneous if. Then right under that, substitutions for that. A function is, the hell was that guy's name? Bernoulli. Bernoulli function looks like this. Substitution is. As long as I don't work one out, I'm good. Talk to me.
You go to 32 now.
Well, now because that right-hand side isn't 0,
Yeah.
we're going to end up using something that's linear instead of something that's separable. So I'll need an integrating factor in my mu thing, right? That means there's a 4x and an e to the something. There's an integration by parts on that side. Yeah. Such predicaments we must forge ahead. That song is older than all of us. Maybe.
But I checking my cases of Wolfram Alpha and I draft them to see if they're the same draft. Different. But I can't figure out where I'm from.
So let's. Which problem are you using? Let's just start with that one. For 2.5 or 2.6? So we're looking at y dx equals 2x plus y dy. Okay, so y space dx equals 2 parentheses x plus y dy. Is there an initial condition on that? No. It gives me a solution there. No, that's just the equation. There's my solution. Isn't that atrocious? And there's the graph with a given initial condition, right? Now, if we didn't actually write an explicit equation, we might not have anything that looks like that. So what did you get for a solution?
Y x over y plus 2 in parentheses times e to the c. Try that thing. First one I gave was the parentheses.
So your solution looks like that. Oh. Like that. Okay, hang on a second. 2e to the c plus x e to the c over y, right? Y squared equals 2y e to the c plus x e to the c. So there's where I see where I get the square root from in the solution on Wolfram alpha. That's a constant in there, right? Constant times, so constant times x under a square root and another constant. So I think the only difference we have is we have a plus c that they don't have. Right? So if I take the square root of this, I get y equals square root. Oh, no, I see what's going on. I have to do the quadratic formula to get this y equals, right? Y squared minus 2e to the cy minus x e to the c equals 0. It looks like that, doesn't it? So A, B, C quadratic formula. That's why the formula looks so different, right? Well, I think that's because of what the C is, right? So if I go to your equation right here, and we put in y of 0 equals 1, then I would have 1 equals 0 over y plus 2 e to the c, right? 0 over 1. So that's 1/2 is e to the c. So I could go back to their equation where they gave me the graph here with y of 0 equal 1. I should get this picture. But that's the difference between an explicit solution and an implicit solution. Here, let me do it a different way. This is the equation you wrote, right? And we just figured out that e to the c was a half. So, here's my function grapher. I'm going to get rid of these equations. Let's edit this one. And we have y equals 1/2 parentheses x over y plus 2, close parentheses, right? Done. If they used the positive part of the square root only, we'd only get the top half, wouldn't we? I think you've got a different value of c. So the question is, what initial condition did you put in versus the thing they gave us? Aha. So that's the problem. I don't know what initial condition gives me c equals 1, right? But I could probably figure out what x and y would work to give that to be c equals 1. That would just be working backwards to get the constant, right? So, but you're not wrong with what you did. You've got an upper part of a parabola. We've got a sideways opening parabola. They're the same shape, but we're at different points, so they're shifted from one another, right? Well, it can't be the same because you've got a different c. But if we could know what point that one went through as opposed to using the point 0, 1, then we could probably map it over. Yeah, this, on the other hand, solving this explicitly, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2, oh dear Lord, right? Yeah, because this 2 will cancel with that 2, and I'll get e to the c plus or minus square root of, I can factor a 4 out of this. That'll be a 2 outside the square root. It'll cancel with the 2 on the bottom. E to the 2c plus x e to the c. Isn't that the answer in Wolfram Alpha? Only they have like 2c1 and c. And then 4c, right? Yeah. That's just the difference in the constant. Hot damn, that's where it came from. Whew. There's nothing quite like checking your answer in the technology going, what the hell did you just tell me? I did this in Calc 2 a couple of years ago. Somebody turned in homework where they'd done stuff on the computer in a section they weren't supposed to. And they came back with the inverse hyperbolic tangent of IZ. First of all, none of them had taken complex variables, so they didn't know what the IZ meant. And secondly, how did you get that? Can you show me the work you did? Nope. This is also why I like implicit solutions, because I have implicit graphers. More questions? I don't have a reason to nail your butts to the chair. Well, there's 7 minutes left, so what do you want to ask me? Bye.